Now we will see the working principle of IC engine, means general working principles of the IC engine. We know that in IC engine converts the reciprocating motion of the piston into the rotary motion of the crankshaft by means of connecting rod. See here, piston is rotating in the cylinder in reciprocating manner, and whatever power that has been generated during the power stroke is transmitted to the crankshaft via this connecting rod. The piston which reciprocating in the cylinder is very close fit in the cylinder. Means we know that during the we can say power stroke, gases are produced which is with high pressure. So to prevent the leakage of gases in the piston cylinder assembly, piston is closely fit in the cylinder through three rings. That is, we can say compression ring as well as oil ring. Rings are inserted in the circumferential grooves of the piston to prevent leakage of the gases from the side of the piston, as I told earlier. Usually a cylinder is bored in a cylinder block, and a gasket made of copper sheet or asbestos is inserted between the cylinder and cylinder head. We have seen in the study of the different parts of the IC engine. At that time we have seen that there is a gasket in between cylinder head and cylinder cover. So this prevents the leakage of the gases and closely fit the cylinder in the cylinder block. The combustion space is provided at the top of the cylinder head where combustion takes place. See here, this is the combustion place inside the cylinder. So as and when after we can say compression stroke, fuel is ignited in the combustion chamber by the spark plug if our engine is two-stroke diesel petrol engine, or it may be ignited through the compressed hot air in case of compression ignition, that is our petrol engine or four-stroke engine. There is a rod called connecting rod for connecting the piston and crankshaft. We know that this is the connecting rod which connects the piston and crankshaft. The pin called gudgeon pin or wrist pin is provided for connecting the piston and the connecting rod of the engine. See here, this is the gudgeon pin which connect the piston and connecting rod. The part of the piston which part of the connecting rod which is attached with the piston is called the small end of the connecting rod. The end of the connecting rod which fits over the gudgeon pin with the piston is called the small end of the connecting rod. See here, this part is connected with the piston with using the gudgeon pin. So this is called the small end of the connecting rod. The other end which fits over the crank pin with the crankshaft is called the big end of the connecting rod. See here, another end, or we can say opposite end of the connecting rod is fit with the crankshaft. So this end is called the big end of the connecting rod. The crankshaft rotate in the main bearing which are fitted the crank. Means for supporting the frictionless movement or frictionless rotation of the crankshaft, there is a crank bearing in the crankcase. So over this bearing, this crankshaft rotates friction freely. So there will be minimum friction by using the we can say ball bearing that is called we can say in the system. The flywheel is provided at the end of the crankshaft for smoothing the uneven torque produced by the engine. As we know that the torque, or we can say force, is produced with jerk, or with, we can say, thrust load in the power stroke. So this thrust load is transmitted on the piston, and then it is transmitted to the crankshaft via connecting rod. So it is necessary to smoothen out this uneven torque. Here this force is, there is a difference between force and torque. See here, force is, the tendency of the force is to cause linear motion. It's simply considered as a force. Means when we apply certain force that produce the linear motion, then this force, this is called the force. But in case when we are giving certain load or force, then it produces the rotational tendency, then it is called the torque. So simply, if we push some object with some force and it produces linear motion, then it is called the force. But as see in the figure, we are applying some force and twisting with the spanner to open either nut bolt or anything, that is called the torque. So rotational force which produce rotational tendency is called torque. So here the flywheel is provided at the end of the crankshaft for smoothing out the uneven torque. See this is uneven torque which is producing twisting force in the crankshaft. So it is called the torque. There is an oil sump at the bottom of the engine which contains lubricating oil for lubricating different parts of the engine. See here, this is the oil sump in which lubricant oil is there. This lubricant oil, either using the pump, or it may be, if it is splash system, then it may be splashed by certain pointed object on the crankshaft. So this sump, or we can say bottom part of the engine, contains the lubricant oil. Now, mechanical cycle of internal combustion engine can completed in two ways. Means there are two type of mechanical cycle in the internal combustion engine. First, when the cycle is completed in two revolution of the crankshaft, it is called four-stroke cycle engine. Means by the we can say two revolution of the crankshaft, we get the one power stroke, and during this two revolution we get four number of stroke. That's why it called the four-stroke engine cycle. See here, four-stroke engine cycle. First stroke, let me understand. First stroke is suction stroke, second is compression, third is power stroke, and fourth is exhaust stroke. So this is the four-stroke engine. Now, second, when the cycle is completed in one revolution of the crankshaft, it is called two-stroke engine. Here, see in the two-stroke engine, one complete revolution of the crankshaft produce one power stroke, and this one power stroke is generated in the two-stroke of the engine. That's why it is called two-stroke engine. The two-stroke of the engine is first is forward stroke, and second is downward, upward. First is upward stroke, and second one is downward stroke. So this is four-stroke engine cycle, and this is two-stroke engine cycle. Now, before going detail in the two-stroke and four-stroke engine, we will go through the terminology connected with the engine power. So first we understand the terminology connected with the engine power. First, top dead center, that is called simply TDC. Position of the piston when it stops at the farthest point away from the crankshaft. Means this is the crankshaft. The piston stop farthest to the crankshaft, means this is the line called the top dead center, where piston ultimately stop, and after that it goes downward. So this is the top dead center, the position of the piston in the cylinder with respect to crankshaft, means farthest from the crankshaft. Now second, bottom dead center, position of the piston when it stops at the point closest to the crankshaft, means position of the piston. See, this is the last position, either in the, we can say, suction stroke or in the power stroke, when piston goes downward and stop most farthest point to the crankshaft. This is the bottom dead center. So in the top dead center, we simply can say the piston stops away from the crankshaft, either in the compression stroke or in the exhaust stroke at the top of the cylinder, or in case of bottom dead center, we can say either in the in the end of the suction stroke or in the end of the power stroke, the piston stop closest to the crankshaft. That is the bottom dead center. See, here exhaust and inlet valves are also seen. Then spark plug in case of two-stroke engine, or if our engine is four-stroke, then there will be fuel injector instead of spark plug. We will see detail in this chapter. Now second is bore. Bore is the diameter of the engine. See, this is the diameter of the engine cylinder and it is called bore. Sometimes the top of the piston, or we can say crown of the piston, the diameter of the crown of the piston is taken as similar as the diameter of the cylinder, because piston closely fit in the cylinder. So sometimes diameter of the cross section of the piston may be termed as a bore, but in general bore is the diameter of the engine cylinder. Now stroke, or we can say length of the stroke. It is the linear distance traveled by the piston from top dead center to the bottom dead center. See, during the, we can say, suction stroke, piston travels from top dead center to the bottom dead center. So this linear distance between top dead center to the bottom dead center is called the stroke. So length of stroke may be determined in terms of we can say top distance between top dead center to the bottom dead center. Now next, stroke bore ratio, means length of the stroke to the diameter of the bore. The ratio of length of the stroke L and diameter of the bore T of the cylinder is called the stroke bore ratio. That is L by D. Here we are taking stroke bore ratio. So length of the stroke L is taken in the numerator and diameter of the D is taken upon this. Now in general this ratio varies between 1 to 1.45. Generally for the IC engine it ranges from 1 to 1.45. If the ratio is 1, then we can say L is equal to D. So we can say diameter of bore is equal to the length of stroke. But if it greater than 1, then up to, it may be up to 1.45. If it is greater than 1, then we can say length of the stroke, or we can say height of the cylinder is more than that of the diameter of bore. And the further, and for the tractor engine, this ratio is about 1.25, means particularly for the tractor engine, the stroke bore ratio is taken as 1.25, means we can say height of the cylinder is 1.25 times more than that of the diameter of bore of the cylinder in case of our tractor engine. Now swept volume or displacement volume, or we can say stroke volume. Here word swept is used. Swept means to wipe off. Means if something is wipe off, then it may come as swept. So swept volume means wipe off volume. See, during the exhaust stroke, we are wiping off or sweeping off the burnt gases from the cylinder. At that time, cylinder moves from bottom dead center to the top dead center. So volume between bottom dead center to the top dead center may be termed as swept volume or displacement volume or stroke volume. See here, it is the volume that is a area of the cross section of the cylinder to the length of stroke, LS, displaced by one stroke of the piston, where A is the cross sectional area of the piston and LS is the length of stroke. See, the diameter of core is we can say D, then area will be pi by 4 D square. The cross sectional area of the piston will be pi by 4 D square, and the length of stroke we generally denominate as LS. Now next is clearance volume. It is the minimum volume of the cylinder available for the charge. Charge may be air, or it may be air in case of 4-stroke engine, or air and air fuel mixture in case of 2-stroke engine, that is petrol engine. When the piston reaches at its outermost point, that is top dead center, during the compression stroke of the cycle, means in the suction stroke, inlet valve opens and the air or air fuel mixture is introduced in the cylinder. After that, during the compression stroke, piston travels from bottom dead center to the top dead center, and ultimately it reaches to the top dead center. At that time, whatever air or air fuel mixture that has been introduced during the suction stroke is compressed in between, we can say, top dead center and the space between the, we can say, upper portion. So this is called the clearance volume. See here, this is the top dead center and this is the line with in between which this clearance volume confined. So this volume is called the clearance volume. It is the minimum volume of the combustion chamber with piston at top dead center. Means as and when piston reaches the top dead center, then whatever space that is available or whatever volume that is available within the, we can say, our combustion chamber, within the, we can say, our cylinder, that is the space called the clearance volume, and it is the volume of the combustion chamber, because during at the time when piston reaches at the top dead center in the compression stroke, in the 2-stroke engine, due to the heat of the compressed air, injected fuel is combust, and in the 2-stroke engine, when the piston reaches at the top dead center in the compression stroke, the spark plug produces spark and ignite the air fuel mixture in the volume which remains in the clearance volume space of our air fuel mixture. Now we will see the here with the pictures the compression ratio. See, this is the top dead center of the piston, and in between the space, this is the, we can say, clearance volume. This is the piston. The diameter of core, that is diameter, either we can consider is a diameter of cylinder or cross sectional for taking cross sectional area, and this is the bottom dead center. Here cross sectional area of the cylinder A is equal to we can say pi by 4 d square. Here by mistake d is not d square is not denoted. So cross sectional area of the cylinder is equal A is equal to pi by 4 d square. See, this is the diameter of bore. So here pi by 4 d square. Displacement of stroke volume displacement or stroke volume Vs means either swept volume or we can say displacement volume or stroke volume. Vs is equal to cross sectional area of the cylinder that is A multiplied by length of stroke L. So pi by 4 d square, that is the cross sectional area of the cylinder, multiplied by the we can say length of the stroke L. We can say L or Ls. Cylinder volume means total cylinder volume. Cylinder volume V is equal to we can see that this is the displacement volume plus we can say clearance volume. So displacement volume Vs, this volume is termed as a displacement volume, and this volume is termed as a clearance volume. So displacement volume plus clearance volume, that makes the total volume of the cylinder. So compression ratio is equal to total volume divided by clearance volume. Total volume of the cylinder is here we have to take Vs plus Vc upon Vc, which is equal to 1 plus Vs over Vc. So this define the compression ratio. Now in the language we can represent it as it is the ratio of the volume of the charge at the beginning of the compression stroke, that is stroke length plus clearance length LC multiplied by cross sectional area of the bore, that is pi by 4 d square, to the volume of the charge at the end of the compression stroke, that is clearance volume Vc, which is equal to the clearance height LC multiplied by area of the bore pi by 4 d square, that is ratio of the total cylinder volume to the clearance volume. Thus we can represent compression ratio as V over Vc, that is equal to, here we have to put Vs, not V, Vs plus Vc divided by Vc, which is equal to 1 plus Vs over Vc. The compression ratio of the diesel engine, that is compression ignition engine, varies from 14:1 to 22:1, and that of the carburetor type engine, that is spark ignition engine, we can say simply SI engine, varies from 4:1 to 8:1. Now we will see the working principle of diesel cycle engine, means our compression ignition engine, working principle of compression ignition engine, or we can say diesel cycle engine. In 4-stroke engine, that is diesel engine, only air is drawn in the cylinder in the intake, or we can say suction stroke, instead of mixture of air and fuel as in case of 2-stroke petrol engine. We will see in this narration. See, in the intake stroke, inlet valve is open and air is sucked in the cylinder during the intake stroke. Compression of the air during the compression stroke makes the charge very hot. Means during the compression stroke, the charge is compressed by the upward movement of the piston. See, here compression stroke start and this compress the charge. At that time both valves are closed. Towards the end of this compression stroke, diesel fuel is injected by the injector in the cylinder in atomized form, which ignites in the cylinder due to the heat of compression. Thus, combustion of the fuel takes place due to the heat of compression, which causes rise in the pressure inside the cylinder, which ultimately force the piston downward for further useful work. See, during the power stroke, we will see as and when this start in the animation. See, in the intake stroke, air is sucked inside the cylinder. Then in the compression stroke, this air is compressed, so it becomes very hot and high pressure. Then fuel is injected, and due to the heat of we can say compression, it ignites the air fuel mixture, and then our power stroke start. And after power stroke, the exhaust stroke is produced. See, this is the power stroke in which fuel is ignited through the heat of compression, and hot gases are produced, which forces the piston downward in the power stroke. No electric ignition system is provided for sparking, as ignition of the charge takes place as a result of heat generated due to the compression of the charges. Means during the compression of the air which is inside the cylinder, during the compression stroke, the pressure upon the air is becomes very high, and also there will be high temperature of these gases. According to the, we can say PV is equal to nRT ideal gas equation. So this heat of compression ignites the fuel as it is injected at the end of the compression stroke through this atomizer, or we can say injectors. Now, four-stroke, we will see the four-stroke engine cycle. In four-stroke engine cycle, all the events take place inside the engine cylinder are completed in four-stroke of the piston. Means, in the cylinder, piston travels four-stroke. This four-stroke completes the entire, we can say, our four-stroke engine cycles. So, here piston makes four-stroke to complete the events. That's why it is called four-stroke engine. This engine has got valve for controlling the inlet of charges and outlet of the exhaust gases. See, this is the inlet valve. This inlet valve permits, or it opens at the time of we can say suction stroke or intake stroke. See, this is the intake stroke during which this valve is open and exhaust valve is closed. So this valve permits the entry of the we can say fresh air inside the cylinder. And after power stroke, as and when the exhaust stroke start, the exhaust valve open, and whatever burnt gases that has been in the cylinder, that has been expelled through the exhaust space or exhaust valve. At that time, exhaust valve is open. The opening and closing of the valve is controlled by cam fitted on the camshaft. Means camshaft is there, which have cam that operates the valve timing system, and through this valve timing system, the valves open or close according to the cycle. So this valve is controlled by camshaft through its cam, that is we can say extended portion on the cam. The camshaft is driven by the crankshaft with the help of the suitable gear or chain, as we have studied in the during the different study of different components of the parts. We have seen that the camshaft gets power to rotate from the crankshaft through the suitable gear or chain arrangement. The camshaft runs at half the speed of the crankshaft. Here, for proper opening of the inlet and exhaust valve, it is necessary to have one revolution of camshaft for every 2 revolution of the crankshaft. So camshaft rotates half the speed of the crankshaft. Now the event taking place in the IC engine are as follows. Means various events that is taking place inside the piston cylinder assembly, or we can say inside the engine, that is chronologically given here. First, air or air pure mixture that we can term as a charge is taken into the cylinder. In case of we can say our 4-stroke engine or diesel engine, only air is taken into the cylinder during the intake stroke, or we can say suction stroke. And in the 2-stroke engine, or we can say in the spark engine, or we can say in the spark ignition engine, air fuel mixture is introduced in the, we can say, suction stroke, or we can say forward stroke of the engine. The charge is compressed in the cylinder by the piston. In the both the cases, charge is compressed by the piston inside the cylinder. The charge, if charge is only air, means in the case of our diesel engine, or we can say our compression ignition engine, or we can say our 4-stroke engine, only charge is compressed. If charge is compressed, only air is compressed. Sorry. If charge is compressed, charge is only air, the fuel is injected at the end of the compression stroke. Means in our diesel engine, or we can say our compression ignition engine, or we can say our 4-stroke engine, only air is taken inside the cylinder during the suction stroke, and fuel is injected at the time when the piston reaches at the top dead center in the compression stroke. At that time, at automized way, fuel is injected inside the cylinder. The charge is injected at the predetermined time under specific pressure inside the engine. Means piston reaches at the top dead center during the compression stroke. So whatever air that has been sucked inside the cylinder in the suction stroke is highly compressed and having high temperature. So due to the heat of compression, whatever charge that has been introduced through the atomizer inside the cylinder at predetermined time, that is ignited through the heat of compression. So that produce the hot gases. The power developed due to the explosive forces of the gases inside the cylinder is transferred to the crankshaft through the connecting rod. Means as and when the fuel that has been introduced in automized way through the injector after the compression stroke, that has been ignited, and it produced the exhaust gases. These gases force the piston, and the piston travels from top to the bottom in the we can say power stroke. That gets the rotational energy, and ultimately it transferred to the crankshaft through the connecting rod. So whatever power that has been produced by the explosion of the fuel, that is transmitted to the top of the piston, and it is transmitted to the crankshaft via, we can say, connecting rod. Exhaust gases goes out of the cylinder at the regular interval. Means in the, we can say, exhaust stroke, in each and every exhaust stroke of the cycle, exhaust gases goes out from the cylinder via exhaust valve, or we can say exhaust opening. See, this is the 4-stroke diesel engine in which 4-stroke takes place. Simply just we will see from see, this is the intake stroke or suction stroke, this is the compression stroke, this is the power stroke, and this is the exhaust stroke. the complete cycle covers all these events in systematic manners. Means these cycles perform in systematic manners inside the engine. 4-stroke cycle engine completes all these events in 4-stroke of the piston, whereas the 2-stroke cycle engine covers all these events in 2-stroke of the piston. In the 4-stroke engine, the various stroke of the pistons are, first we can say suction stroke, second compression stroke, third power stroke, and fourth exhaust stroke. This figure represent the 4-stroke in 4-cylinder IC engine. Here the engine is 4-stroke engine and having 4-cylinder. So for understanding the different stroke, 4-stroke engine with different 4-stroke is represented here. See, this is the suction stroke, or we can say intake stroke. During the intake stroke, inlet valve opens and exhaust valve closes. So, due to the downward movement of the piston, air is introduced inside the cylinder. After that, the piston reaches travels from bottom dead center to the top dead center, and at that time both the valves are closed, and whatever air that has been introduced during the suction stroke is compressed in the engine cylinder. So this is the compression stroke. At the end of the compression stroke, piston reaches at the top dead center, and whatever air inside the cylinder is compressed in the, we can say, clearance volume of the cylinder. Then at that time, the air fuel is injected through the injector, and this compressed air is too hot, having high temperature. So due to the heat of compression, whatever fuel that has been injected, that gets to start burning, and it produces high hot gases with high pressure. So it exerts pressure to the piston, and piston travels from top dead center to the bottom dead center. That is, we can say, power stroke, or we can say combustion stroke. In this stroke, piston travels from top dead center to the bottom dead center. After that, piston reaches to the bottom dead center, and in the power stroke both the valves are closed. But as and when the piston reaches to the bottom dead center after power stroke, then it travels from bottom dead center to the top dead center. At that time, exhaust valve remain closed, and whatever exhaust gases that has been produced during the power stroke is then expelled out through the exhaust opening out of the cylinder. So this figure represents all the four stroke of the 4-stroke engine through the various we can say position of the cylinder piston. You can see here this is the main bearing which is fitted in the crankcase to rest the crankshaft, and this is the, we can say, connecting rod bearing which allows the assembly of we can say connecting rod and our crankshaft to rotate friction freely. Now we will see systematic all the four stroke. First we see the suction stroke. See here, during the suction stroke only air or mixture of air and fuel in case of the, we can say, 2-stroke engine are drawn inside the cylinder. The charge enters the engine through the inlet valve which remains open during admission of the charge. Means here you can see there the suction stroke piston travels from top dead center to the bottom dead center, and at that time inlet valve opens and exhaust valve is closed. The exhaust valve remains closed during this stroke. The pressure in the engine cylinder is less than the atmospheric pressure during this stroke, as the piston travels from top dead center to the bottom dead center. So therefore there will be vacuum inside the cylinder. So pressure inside the cylinder remains below the atmospheric pressure. So naturally, through the inlet valve, or we can say opening of inlet valve, or through the opening of inlet, naturally air will comes in the cylinder due to the vacuum pressure inside the cylinder. We can represent here that as a suction stroke 1 to 2. Piston moves from TDC to BDC. Piston moves from top dead center to bottom dead center. Intake valve open, means intake valves remain open to introduce fresh air inside the cylinder. Exhaust valve closed. Here exhaust valve is closed. Engine pulls piston out of the cylinder, means engine is pulling piston out of the cylinder, means outside the cylinder, means piston is moving downward. Low pressure inside the cylinder. Here, due to the increase in the volume of the cylinder, there will be vacuum pressure or low pressure inside the cylinder. Air fuel mixture enters into cylinder. In case of, we can say, if our engine is of spark ignition, or we can say petrol engine or carburetor type engine, then in that case air fuel mixture enters in the cylinder. Flywheel angle of rotation is 0 to 180 degree, means totally 2 revolution occurs in the cycle. So in the suction stroke, flywheel rotation will be 0 to 180 degree. Engine does not work on the gases during this stroke. Means engine does not work on the gases. So there will be no pressure on the gases by the engine during this stroke. Now second is compression stroke. That is represented by 2 to 3. The valves, the charge taken in the cylinder is compressed by the piston during this stroke. Means piston travels from, we can say, bottom dead center to top dead center, and at that time both the valves are closed. So charge that has been taken in the suction stroke is compressed by the piston during this stroke. The entire charge of the cylinder is compressed to the small volume contained in the clearance volume of the cylinder. Means as and when the piston is at the top dead center, the entire charge is confined within the clearance volume of the cylinder. So with the high pressure and due to the compression of the high pressure, the air within the we can say clearance volume will be hot, or we can say its temperature will be too high and having very much high pressure. So at that time both the valves are closed. Now different events of the compression stroke is also given here. Pistons move from PDC to TDC, PDC to TDC. Intake valve closed, exhaust valve closed, means both the valves are closed. Engine pushes piston into the cylinder, means engine is pushing cylinder upward, means piston is moving in the cylinder through the force that has been stored within the engine from bottom dead center to the top dead center. Mixture is compressed to high pressure and temperature. In case of, we can say, 2-stroke engine, there will be air fuel mixture. In case of 4-stroke engine, only air is present, so it is compressed inside the cylinder in the confined space. So it gains the high pressure as well as high temperature. Then flywheel angle of the rotation 180 to 360 degree. As we have seen there in the suction stroke, flywheel rotation was 0 to 180 degree. So in the compression stroke, its rotation it rotates further 180 degree. So it becomes 180 to 360 degree. Engine does not work on the gases during this stroke. Means engine is not working on the gases during this. Engine does not work on the gases during this stroke. Now see little explanation. In the case of diesel engine, we can say in the compression ignition engine, only air is compressed in the cylinder and the fuel is injected at the end of the compression stroke. The ignition take place due to the high pressure and high temperature. That we can say the heat of compression of the compressed air. In case of the spark ignition, or we can say in our petrol engine, the mixture of air and fuel is compressed in the cylinder and the mixture is ignited by the spark plug. See, this is the 4-stroke engine in which ignition takes place after the end of the compression stroke due to the heat of compression inside the hot air which has remained in the clearance volume. So at that time we are injecting the fuel with the injector in the automized way, and that automized way injected fuel is ignited by the heat of compression. No need to have spark plug for igniting the fuel in case of our 4-stroke diesel engine. But in case of 2-stroke engine, air fuel mixture is not so much compressed, so we need spark plug to ignite the air fuel mixture. So in the 2-stroke engine, or we can say in the spark plug engine or our petrol engine, we have made the arrangement of spark plug to produce the spark for the ignition of air fuel mixture. After ignition, tremendous amount of heat is generated, causing by high pressure in the cylinder, which pushes the piston backward for useful work. Means after, we can say, ignition of the air fuel mixture, or we can say our fuel, there will be explosion of the gases, and that exploded gases produce high pressure over the top of the piston, and piston is forcefully diverted to move downward in the cylinder, and this pushes piston downward, and the power is then travel from piston to the crankshaft via connecting rod, and this force, or we can say energy, may be utilized for further useful work through, we can say, our crankshaft. Both valves are closed during the stroke. Means during this power stroke, both valves are closed. Now we will see the power stroke, event 3 to 4. During power stroke, the high pressure develops due to the combustion of fuel, which causes the piston to be forced forward or backward at the regular interval. Means only power stroke in case of 4-stroke engine is the stroke in which power is produced. So due to the combustion of, we can say, fuel at the end of the compression stroke, which is injected by the injector inside the clearance volume of the cylinder, power is produced, and that power is ultimately transferred to the top of the piston and then to the crankshaft via connecting rod. And this power is the power which can be utilized for further forward or backward movement of the piston inside the cylinder for each and every cycle, or each and every revolution of the piston cylinder assembly. The connecting rod, with the help of the crankshaft, transmit the power to the transmission system for useful work. Means whatever load or force that has been exerted upon the top of the piston, that is transmitted to the crankshaft via connecting rod, and this power or energy which has been gained in the, we can say, our crankshaft may be transmitted for further useful work, either to run the tractor on the road, or to pull the implements for different works in the farm by the tractor. So ultimately we can convert this power or energy into useful work via certain instrument, equipment, or whatever we use through the transmission system of the engine. Both the valves are closed during this stroke, means during this power stroke both the valves are remain closed. Here we can you can see the in the 4-stroke engine, or we can say our petrol engine, or we can say our compression engine, fuel is injected through the injector. But in case of 2-stroke engine, or we can say our petrol engine, or we can say our spark ignition engine, here spark plug is there. Air fuel mixture is introduced from the inlet valve or inlet port in case of 2-stroke engine. The event taking place in the power stroke is explained here. Piston moves from top dead center to the bottom dead center. Means in the power stroke, piston moves from top dead center to the bottom dead center. Intake valve closed, exhaust valve closed. Means both the valves remain closed. Mixture burns to form hot gases. As and when the mixture is ignited, it burns and produces hot gases which are having high pressure. Gases pushes piston out of the cylinder due to the high pressure, or we can say explosion of the gases. It pushes the piston downward inside the cylinder. Gas expands to lower pressure and temperature. Means due to the downward movement of the piston, the gas expand inside the cylinder. So its pressure becomes lower, and also its temperature is also reduced according to the natural gas equation. PV is equal to nRT. Flywheel angle of rotation 360 degree to 540 degree. As we know that we have completed we can say 360 degree rotation in suction and compression stroke. So in the power stroke, flywheel rotates from 360 degree to 540 degree, means 180 degree rotation. Goes gases to work on engine during this stroke. This is the only stroke in which hot high pressure gases that has been produced by the explosion of the or burning of the fuel that works on the engine and produce useful power for doing further work. So gas do work on the engine during this stroke. This is the, we can say, power stroke in which we can get the energy. Now next stroke is the exhaust stroke. That is, we can say 4 to 1. Exhaust gases goes out through the exhaust valve during this stroke. Means during this stroke, piston travels from bottom dead center to the top dead center, and at that time exhaust valve is open, through which exhaust gases or burnt gases goes out in the atmosphere, and at the same time inlet valve is closed. So whatever exhaust gases inside the cylinder that has been forced to expel out through the exhaust opening in the atmosphere, all the burnt gases goes out of the engine, and the cylinder become ready to receive the rest charges. Means as and when the piston reaches at the top dead center, all the exhaust gases is expelled out from the cylinder. So during the next cycle of the engine, in this suction stroke, piston is now cylinder is now ready to receive new charges, or we can say fresh air inside the cylinder. The inlet valve is closed and exhaust valve remain open during this stroke. During this, as I have told, for expelling out the exhaust gases, exhaust valve remain closed and inlet valve remain, exhaust valve remain open and exhaust valve remain closed. See this figure. Thus, it is found that out of the 4 stroke, there is only 1 power stroke and 3 idle stroke. Means our suction stroke, compression stroke and exhaust stroke are the idle stroke. Only power stroke is the stroke in which we are obtaining the energy or power to run our engine cycle, as well as to get energy for further useful work. So 3-stroke is idle stroke, and power stroke is the only stroke which is, we can say, stroke which produce the energy. The power stroke supplies necessary momentum for useful work. Means whatever energy that has been produced during the power stroke, which helps to run either, we can say, our engines system, or to do the useful work. This force gives the momentum to the instrument, equipment, whatever, or for the transportation from one place to another place of our system engine, gets the energy. See the phenomena of the exhaust stroke from, we can say, 4:1. Piston moves up, means from bottom dead center to the top dead center. Intake valve close, exhaust valve close. Both the valves, intake valve close, exhaust valve open. Engine pushes piston into cylinder. Engine pushes piston. Here, engine pushes piston into cylinder. Piston is pushed inside the cylinder upward. High pressure inside cylinder. Due to the power stroke, the pressure inside the cylinder is high. Pressure pushes burnt gases out of the cylinder. Means due to the force of the piston in the upward direction, the all burnt gases that goes outside the cylinder through the exhaust opening into the atmosphere. Flywheel angle of rotation is 540 degree to 720 degree. Means further 180 degree rotation of the flywheel in the exhaust stroke. Engine does not work. Engine does not work on the gas during this stroke. Means during this stroke, engine is not working on the gases. Now we will see the 2-stroke cycle spark ignition engine, or we can say our petrol engine. First we will see the principle. The principle of the 2-stroke cycle spark ignition engine is shown in the figure. It is 2-stroke of the 2-stroke are as follows. Means we can see this figure represent the 2-stroke engine cycle, principle of the 2-stroke engine cycle. This figure represents the upward stroke, and this figure represents the downward stroke. We will systematically learn about the upward stroke and downward stroke. This 2-stroke, upward stroke and downward stroke. First we will see the upward stroke. During the upward stroke, first we will see the figure, what it indicates or what it is representing. In the 2-stroke engine, or we can say in our spark ignition engine, or we can say our petrol engine, instead of valve there is a port for introducing air fuel mixture and releasing the burnt gases after the power stroke. See, this is the, we can say, inlet valve or inlet port through which trace air fuel mixture is introduced in the crankcase. So fuel mixture, or we can say air fuel mixture, is drawn into the crankcase through this port. This is called inlet port. This through this opening it goes and transferred to the engine cylinder. This is called the transport port. So at a particular instant it opens, then fresh air fuel mixture is introduced in the cylinder. this is the exhaust port. So here for introducing the fresh air fuel mixture in the crankcase, this is the, we can say, inlet port. Introducing this air fuel mixture inside the cylinder, it is introduced through the transport port, and whatever hot gas or burnt gases that has been produced during the power stroke is expelled out through the exhaust port. This is the exhaust port. Now we will see how it works during the upward stroke. During the upward stroke, the piston moves upward from the bottom dead center to the top dead center. Means in the upward stroke, piston moves from bottom dead center to the top dead center. By compressing the charged air petrol mixture in the combustion chamber of the cylinder, means whatever charge that has been introduced earlier is compressed in the upward stroke of the piston, traveling from bottom dead center to the top dead center. So air fuel mixture, here fuel is petrol because we have two stroke cycle. So air and petrol mixture is compressed inside the cylinder during this upward stroke. Due to the upward movement of the piston, the partial vacuum is created in the crankcase and the new charge is drawn into the crankcase through the uncovered inlet port. See, piston is moving upward. So at that time, our inlet port is uncovered. It is open. So fresh air fuel mixture, fresh air and petrol mixture is introduced inside the crankcase. This is the crankcase portion. So as piston moves upward, then this port become uncovered, and through this port air fuel mixture is drawn into the crankcase. So we are charging the crankcase through fresh air fuel mixture. Now further, the exhaust port and transport ports are covered when the piston is at the top dead center. Means when the piston reaches at the top dead center, at that time this exhaust port as well as transport port both are covered by the piston. The compressed charge is ignited in the combustion chamber by the spark plug given by the spark plug. See, this is the spark plug. So at the end of this forward stroke, piston reaches at the top dead center, and at that time a spark is produced by the spark plug which ignites the compressed air fuel mixture remains within the clearance volume of the cylinder. So this here combustion takes place inside the cylinder. So it's over the, we can say, forward stroke. Now in the down, we can say our upward stroke. Now our downward stroke. We will see first figure. Simply in the downward stroke, our piston moves from top dead center to the bottom dead center. So simply at that time, first our exhaust port will uncovered. It will remain. It becomes open because it is on the upper side. Then the we can say our transfer port as well as inlet port. So first uncovered the we can say our exhaust port and then transport port, and after that in the forward stroke this port will be uncovered. As soon as the charge is ignited, after the end of the forward stroke, when piston reaches the top dead center, the hot gases produced which compress the piston to move downward. Means here charge is ignited due to the charge produced by the spark plug, and hot gases is produced due to the burning of the air fuel mixture, which compress the piston, and piston is forced to travel downward, which ultimately rotates the crankshaft to produce useful work. Means downward movement is transferred to the crankshaft via connecting rod, and this rotation of the crankshaft may be utilized for further useful work in the engine system. During the stroke, in the starting, the inlet port is covered by the piston. See here, inlet port is covered at the starting when piston is moving from top dead center to the bottom dead center, and further downward movement of the piston compresses the new charges in the crankcase, and further if piston goes downward, then this downward movement of the piston compresses the charges which remains inside the crankcase. So downward movement of the piston first covers the inlet transfer port, and then it compresses the charges that has been remained in the crankcase. Thus, further downward movement of the piston uncovered first the exhaust port. Then now if the piston goes downward, then see this is the downward position of the piston. In that case, we can say first upper port, that is, we can say our exhaust port is uncovered. So whatever exhaust gases that has been produced through the burning of our air pure mixture goes outside the atmosphere. So uncovering the exhaust port, exhaust gases start to expel through the exhaust port, and further downward movement of the piston means uncover the transport port. Transport port means piston. If piston reaches here, top of the piston reaches here, then this transfer port become open. So whatever charges that has been inside the crankcase with the high pressure may be transferred in the, we can say, toward the inlet port, and it may travel from inlet port to the, we can say, our cylinder. Thus, further downward movement of the piston uncovered first the exhaust port. See, this is the exhaust port. Hence, the exhaust gases starts through the exhaust port. This exhaust gases start to expel through the exhaust port, and then further downward of the piston uncovered the transport port, means transport port is uncovered. Now, afterward, as soon as the transport port is open, see this is the open position of the transport port, where piston is much lower and it has covered the, we can say, inlet port. Further downward movement of the piston compresses the charge to enter into the cylinder, means whatever charge is inside this system, that compressed to enter in the cylinder. Thus, the incoming charge strikes to the deflector on the piston crown, and it rises to the top of the cylinder. Thus, it pushes out most of the exhaust gases via open exhaust port. This is the, means as and when this new charges enter in the cylinder, then it strikes over the top of the piston. From that it deflects and rises upward, and during that its upward movement, it pressurizes the exhaust gases to expel out from the, we can say, our exhaust port. The piston is now at the bottom dead center position, means completely piston reaches at the bottom dead center, and at that time it covers the inlet port, and both the ports, transfer port as well as exhaust port, are uncovered. The cylinder is completely filled with fresh charge, although it is somewhat with the exhaust gases, means due to the movement of the charges from the transporter port inside the cylinder is completely filled with the fresh charges. But as there is a mixing of intake as well as exhaust stroke in this system, so some exhaust gases may not expel out from the cylinder. So there may be rest charges inside the cylinder as well as somewhat exhaust gases may be there inside the cylinder. The cycle of events is then repeated. The piston making two stroke for each revolution of the crankshaft. Means this cycle is repeated for every, we can say, one stroke, and piston makes two stroke in every one revolution of the crankshaft. So in every revolution of the crankshaft we get one power stroke in two stroke engine, or we can say our petrol engine. See this figure, this animation represent how our two stroke engine, or we can say petrol engine, or we can say our spark ignition engine works. If you see during the upward stroke, the charge is, we can say, compressed, and this port remains open. So whatever charge that comes in this system, so we can say our charges enters from crankcase to this system, and then down in the downward movement, it is again compressed and goes inside the transfer port, and then it is fed up the cylinder during the downward movement, and the new fresh charges that comes in the cylinder that expel out the exhaust gases from the cylinder which have been produced during the power stroke. This system represent the two-stroke cycle of the engine. Say this is the main figure which represent the principle of the